Students, I hope you are all doing well, and I pray for your health and safety under these tough situations. Let us go into our course. Sorry, we are. I have been, as you all know, I've been already uploaded some of the course material into Blackboard, and this is the additional for that, which is related to the optimization. We have done graphical method of optimization, which is limited to maximum of 2 variables, and so that's its con. And if variables are optimizing variables are more than 2, we have to use this simplex method of optimization, as I have already given in our course before midterm. Now we're going to look into simplex method of optimization, and I've been already uploaded its material and some of the problems, a video. But let us solve another example, and I'm going to upload this video for you and this notes for you. Just look into it. So this has chapter 8 and page number 62. The simplex method is being explained. I have already uploaded to Blackboard before week, and here I'm going to solve problem 1 in page number 59. The same problem we have already solved by graphical method of optimization. So simplex method, as I have already explained, is it will be applicable if the variables, optimizing variables, is 2 and more. Okay, you can apply even for 2 also, but more than 2 you can use must simplex. The same problem, the heat exchanger and the area problem, area for heat exchanger and reactor. That problem, the first step is, when the problem is given, you have to set up a optimization problem like this, which we have already done this, which has a main equation, which is a objective function. Here is the objective function is the profit function, which is in dollars, 1500 times x plus 900 times y. Here x is area allocated for the installation of heat exchanger, and y is the area is allocated for the installation of a reactor. And these are all subject to some constraints, inequality constraints. I believe this is the budget constraint, this is the time constraint, this is the area constraint. These two are common constraints. So once you set up a problem, optimization problem like this, then go to the next phase. So in the next phase here is, you have to set up in simplex method, you have to set up a simplex table. You have to set up a simplex table, and once you set up this simplex table, you have to do some row operations, and at the end you will get the optimized variables and the maximum profit. So when you have this optimized problem, setup of the optimization problem, so you have to guess in the beginning, in the guess, choosing initial guess, because it is a just guess. Make x and y 0. Before that, bring in the profit function, you see here the profit function, bring these two variables to left hand side, so it will become negative, right? So minus 1500x minus 900y plus profit is equals to 0. So choose initial guess as x and y 0, so it will become the initial profit is 0. So initial profit is 0. And then after that you have to set up a simplex table. You have to set up a simplex table from the constraints equation and from the objective function. So before that, as like in the graphical method, similar to the graphical method, we have to remove inequality constraints. Here also we should remove inequality constraints. See here, so there we didn't add any extra variables, but here you must add an extra variable for removing of inequality constraints. If you see the first variable, the first constraint here, 600x plus 300y less than or equal to 3600, right? So we have to remove the inequality constraint and add a variable. So these variables are called slack variables. variables. So in the first equation, add one variable s1 slash variable 1. In the second equation, add a second variable s2, and third is s3. So when you do this one, now you have to set up a simplex table into matrix form, write all these equations as a matrix form. This is called simplex table. So you have to write all the left hand side is one side and all the right hand side is one side. All the left hand side is known as you all know, matrix, coefficient matrix, right? And the right hand side is scalar matrix. All are in one matrix. See here, all are one matrix, but the right hand left hand is separated by just line, by a line, because right hand side there is no variable, right? That's why it's called as scalar matrix. So what variables we have here in the left hand side? X, Y, S1, S2, S3, right? So X, Y, S1, S2, S3. So write in the first equation what are the variables, coefficients before these, behind these variables. What is the coefficient of X? 600. Coefficient of Y? 300. Coefficient of S1? 1. Coefficient of S2, S3? 0, 0. But why? Since there is no S2, S3 in equation 1. And then the right hand side. Make a line here, separate from left hand to right hand. And the right hand, the scalar value is 3600. Then go for second equation. So what is the coefficient of X? 1. Coefficient of Y? 2. Coefficient of S1? 0, because there is no coefficient of S1 coefficient. Coefficient of S2? 1. Coefficient of S3? 0, since there is no S3 in equation 2. In the third equation, the third constraint equation, this one. So both coefficients of X and Y, 1, 1, 0, 0, 1, because S1 and S2 are not there in the third equation. In the right hand side, scalar matrix 10 here, and second equation 12. Then again separate a line here horizontally, and right here, okay, the profit function by assuming this one. When you bring all the variables to this side and make equal to 0, minus 1500x minus 900y plus p equal to 0, right? So what is the x variable coefficient of x? Minus 1500, right? What is the coefficient of y? Minus 900, right? And there is no slack variables, right? Because y, it is already a equality equation. So there is no S1, S2, S3. What is the right hand side? The initial profit 0. The initial profit P is 0, right? This one. So now once you set up in the matrix form, now you have to do some row operations to find out optimum X and Y and maximum profit. Maximum profit you will find here at the end of all the problem. Okay, and how to do row operations is now key point, right? So you have to do some row operations in such a way that there should not be any negative number in the last row. So when there is no negative number in the last row, stop all the operations and then find out optimum X, Y and maximum profit. For that, the first step is you have to find out, before doing any row operations, you have to find out some steps. You have to follow some steps. What are they? First, you have to find out the most negative element in the indicator row. What is indicator row? So the last row is known as indicator row, as you all have seen in the YouTube video which have been uploaded, right? And the last row is indicator row. So choose what is the most negative element. That is a what will become that? That column will become pivot column. What is here the most negative element here? Minus 1500, right? So corresponding to that column is known as pivot column. See here, the pivot column. The next step is you have to find out the pivot row. You have to find out the pivot row. So how to find out that one? You have scalar matrix, right? And you have a pivot column. The corresponding values, those pivot column and the last scalar column, find the ratios. 3600 here over 600. What is the ratio? 6. And 12 over 1 is 12. 10 over 1 is 10. So to find out the pivot row, okay, you have to choose the least row, least value. What is the least value? The first one, right? So because of that, see here, calculate the ratios between scalar and the corresponding elements of pivot column and choose the minimum ratio, so that corresponding row will become pivot row. Okay, so the common element in the pivot column and the pivot row is known as pivot element, the pivot element. So when you do this one, you have to do the then proceed the problem, and you have to do some row operations. You have to do perform some row operations. So in those row operations, you have to make the pivot element 1, and the remaining all the elements in the pivot column zeros by row operations. How can you do this here? First, you have to make the pivot element 1, right? How you do that? Only remember that, my dear students, only by performing row operations. Okay, so you have to divide all this row by 600, then only the pivot element will become 1, right? So do this one. Okay, the first row, the new capital R is the new row here. So capital new row will become the old row divided by 600. See here, 600 divided by 600 will become 1. 300 divided by 600 will become 0.5, right? So the first row divided by the 600, you get all these new values. You get all these new values. The remaining values, write as it is, right? As it is. Okay. Then, as I said, except the pivot element, the remaining elements in the pivot column should make 0, 0. How you will make that? So new row, this row 2 minus row 1. So you will get this will become 0, and R3 minus R1, this will become 0, and R4 plus 1500 times R1, then you will become, this will become 0, because here you have negative 1500, right? So you have to add 1500. For that, you have to multiply all this row 1500. So R4 will become R4 plus 1500 R1. Okay, so when you do all these operations, you will get, at the end you will get this table. Okay, what's have here? So this is the new table. And is it the end of the problem? No. As I said, the last row is known as indicator row, right? As I already explained, you have to perform these row operations until you see there is no negative number in the indicator row. I think we are finding one negative value, right? Only one negative still remaining. So you have to perform the same operations as if we have done before. So what is that? In the choose the negative element in the indicator row. If there is only one, choose that. If there are more, choose the most negative element. So this is the only negative element here. So this will become a pivot column, right? And you have to choose, next is pivot row and pivot element. For that, you have to find the ratios, right? Ratios of this column and the scalar column, right? So 6 over 0.5 will become 12, right? And 4 divided by 0.6 divided by 1.5 is 4. And 4 divided by 0.5 is 8. Don't do the ratio for the indicator row, only the constraints row only, okay? So which is the least ratio? The second one, right? So this row will become, second row will become pivot row, and the common element between the pivot column and pivot row is pivot element. Except pivot element, make pivot element 1 by row operations like before. All other elements except the pivot element make 0, 0. See here, make this one 1. How you do that? All this row, you cannot do only to this element, you should do row operations. So all this row should divide with 1.5, then you get this 1. What you should do next one? Do perform some row operations so that except this one, make others 0, 0. How you do that? By these row operations. R1 will become R1 minus 0.5 R2. So this is the new row, new matrix table, new simplex table. So you see now, this table is after performing all these row operations. So you see here, this is the pivot element, right? Except this one, make all others 0, 0. So if you see now, shall we continue the row operations further? No need. Why? If you see now, the last row, indicator row, is no negative value. So that this is the indication to stop the any row operations. So now, read here, since all the elements of the indicator row are non-negative, this forms the simplex table. So this is the final simplex table. No need to do any more operations. Okay. Now we have to, in the beginning, what we have done, we have converted equations into a table. Now we have to convert equation table into equations, right? So first write the first constraint equation. What is this equation? First constraint, second constraint, third constraint, and last indicator row. What is this one? In the beginning you assume initial profit is 0, right? So what is our objective here? At the end, we have to find out optimum value for the x, optimum value for y, and the maximum profit from these areas. What is x? X is the area for the heat exchanger, y is the area for the CSTR, right? Now write the equation. So these are the coefficients, right? 1 times x plus 0 times y plus this times s1, this times s2, this times y3 is equals to the scalar, is the last right hand, right? Is 4. So if you do this one, and the second equation is this one. Second equation is this one, okay? Now, as I said, S1 has to assume S1, so S3 is 0, right? In the first two equations, assume S1 is to 0 because they are not they are negligible, okay? So, because see here the coefficient is very low and S1 will become very low also. So, assume S1 is to 0. So, what will happen here? If you assume S1 is to 0, assign a value 0 to the variable corresponding to non-zero element in the indicator row. So means all these will become 0 0 in indicator row. So here there is no 0 because 0 times y, we assume s1 is to 0, s3 this is already 0 anyway. What left here in this equation? Only x. X is equals to 4. And the second equation is what? 0 times x because coefficient, right? And 1 times y plus all these are like this. So assume s1 is to 0, there is no s3 because 0 times, there is no x 0 times. So what left here in the left hand side? Only y. Y is equals to 4. So maximum profit is, how you get that? This one. Maximum profit is, here is the $9,600. In another way also to find the maximum profit, substitute x and y in the profit function. In the profit function, as I said before. In this profit function, substitute here if x equal to 4. 1500 times 4 is how much? 6,000, and 900 times 4 is 3,600. So 9,600 the profit is. So both should get same value here, and when you substitute x and y in the profit function, both should be same. That is the cross check to check your answer. The maximum profit is 9,600. Okay. So in any way, in any problem, the same procedure you must follow. The first step is convert into a setup optimization problem and remove inequality. Set up a simplex table, do some row operations by this method, and perform the row operations until you see no negative value in the indicator row. When you do that, write in the equations and assume s1 is to 0, and you will find out easily these values. Okay, so that is the end of the simplex table. I'm going to upload this into Blackboard, so just make a note. With the same procedure, perform other solve other problems which I have already uploaded in the last week. I wish good luck and safe everyone. Thank you. If you have any problems, just I open a discussion board in the Blackboard. Just do ask me questions there. Thank you.